Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to discuss a few past paper questions from International A-Level Edexcel S1 Statistics 1, and the topic is probability, particularly the questions of tree diagram and Venn diagram, which are mostly tested in S1 past papers. So first of all, we have S1 January 2023, question number 2, IAL paper. So it says that two bags X and Y each contain green marbles and blue marbles only. And then it says that bag X contains five green marbles and four blue marbles. And bag Y contains six green marbles and five blue marbles. So here I've made the summary for this. In bag X, you have five green and four blue, so total is nine. And in bag Y, you have six green and five blue, so total 11. And then it says that a marble is selected at random from bag X and placed in bag Y. Okay, so a marble is selected from bag X and it is placed in bag Y. Then a second marble is selected at random from bag X and placed in bag Y. First two marbles are selected from bag X and placed in bag Y. And then a third marble is then selected, this time from bag Y. Okay, so first two are selected from bag X and placed in bag Y, and third marble is selected from bag Y. So this scenario you need to remember over here. Okay, so the requirement of part A is to use this information to complete the tree diagram shown on page 7. So here I've brought the screenshot of the tree diagram which was printed on page 7 in the paper. So we need to complete this. Okay, so what we know the fact is that first two marbles are selected from bag X and placed in bag Y. And then the third marble is selected from bag Y. Okay, so when the first marble from bag X is selected is green. So, as we know the summary that the total marbles in bag X is 9, out of which 5 are green and 4 are blue. So, if you are picking the first marble from bag X, which is green marble, so the probability of green marble is 5 over 9. Okay, and then after this, if you are selecting a green marble from bag X, okay, so obviously, one marble is gone into the bag Y. Makes sense? So the total marbles in bag X are now remaining 8. 8 marbles are remaining in bag X. Okay. And now, since one green is selected, so 4 green are remaining. So here you have 4 over 8. And now in this way, we need to complete the tree diagram. Okay, so the third marble is selected from bag Y in this whole scenario. Third marble is always selected from the bag Y. Okay, bag Y originally had 11 marbles, and first two green marbles were selected from bag X and placed in bag Y. So now the bag Y has 13 marbles. Originally, bag Y had 6 green marbles, and after the two first green marbles are placed in bag Y, so bag Y has now 8 green marbles, so 8 over 13 over here. Simple. Okay. Then green, green, blue, meaning the first two marbles which are selected from bag X are green, and the third marble which is selected from bag Y is blue. Okay. So what you need to understand is that in order to fill this value, you can just use the fact that the sum of these two values will be equals to 1. So 1 minus 8 over 13 will obviously give you 5 over 13. 1 minus 8 over 13 will obviously give you 5 over 13. But if you individually consider the way you consider the above value, okay, so in the third attempt, when you are going to select a marble from bag Y, so two marbles have already been, you know, shifted from bag X into bag Y. So total 11 plus 2 marbles in bag Y, which is 13 marbles. And when the first two ones were green, so bag Y was containing originally 5 blue marbles. Okay. So obviously the two marbles which are added from bag X are green. So blue is originally 5. So therefore the probability of, blue marble in bag Y is 5 over 13. As simple as that. In the same way, you need to fill the complete tree diagram over here. Okay. So now if the first marble from bag X was green, so second marble which is blue from bag X, the probability is 4 over 8. So then we need to see green, blue, green now. Meaning from bag Y, we need to find a green marble. Okay. So first marble from bag X was green. Okay. So it was placed over here. And then you select a second marble from bag X and place it into bag Y, and the second one was blue. So now bag Y contains 11 plus 2 marbles, which is 13. Okay, so the total marbles in bag Y, they are 13 when you are going to pick the third marble from bag Y. Originally bag Y had 6 green, but when you selected the first marble green from bag X, this was shifted into bag Y. So now bag Y contains the green marbles, which are 7. Originally there were 6 green marbles in bag Y. Now there are 7 green marbles in bag Y. So this is 7 over 13. And as far as this value is concerned, so 1 minus 7 over 13, this will give you 6 over 13. Or you can just individually think about it the same way which I explained these two scenarios over here. Okay. You just need to write down the values over here without any working. You just need to think about them. Okay, so as quickly as possible and as effective as you can make this thing. Okay, so that's basically the whole idea. Now, when you select the first marble from bag X, which is blue. So originally bag X had 4 blue marbles. So 4 over 9. 4 over 9. Okay. And then you go to pick up a second marble from bag X. Okay, so basically when bag X originally had total marbles 9, so now 1 is gone in bag Y, so the total remaining are 8. Okay, and when you choose a green marble in this case, so originally there were 5 green, now 1 blue is now removed, so green will remain the same. Okay, because when you selected the first blue marble from bag X, so green marble remains same, right? They are 5. It will not be affected. So this will be 5 over 8. However, if you select the first marble blue from bag X, okay, so originally bag X had 4 blue marbles. Okay, now 1 blue is gone, so the remaining blue are 3. So 3 out of 8. As simple as that. Or you can just simply use the fact that, in order to find this value 3 over 8, 1 minus 5 over 8. This will give you 3 over 8. Okay, and this one is already completed over here. So in this way, we have filled the tree diagram over here, and part A is done. Now in part B, it says that find the probability that the two marbles selected from bag X are of different colors. So now this question is quite simple for you because the tree diagram is already completed. So now let's move on to the solution of part B on the next page. So I've got the screenshot over here, okay, for the tree diagram which we already completed on the previous page. So the requirement is to find the probability that two marbles selected from bag X are of different colors. So this means, we are talking about the first two marbles only. because first two marbles are selected from bag X. So this means either green and blue or blue and green. Okay, first green, then blue, or you can say first blue, then green. Either this case or this case. So when you go along the tree diagram, along the branches of the tree diagram, the probabilities are multiplied. And when you move vertically along the tree diagram, the probabilities are added. Okay, so you need to be well aware of these basic concepts which you have already studied before attempting the past paper questions. Before attempting the past paper questions, before watching these videos, you must be well versed with all of the basic concepts. Okay, otherwise there is no advantage of attempting past papers without clarity of your basic concepts. Okay, so either you can say green blue or you can say blue green. Okay, and this basically the values on the tree diagram. Okay, this is basically a way of representing the conditional probabilities over here, meaning when you pick a second marble from bag X, which is blue, after the first one, which was green. So this is basically exactly the same thing as saying that you are finding the probability of blue given that green has occurred. This is basically a conditional probability. Okay. However, expressing this in a symbolic form is not a compulsion. You can just start your working by using these values over here. Okay. So this is basically the whole idea. So mentioning the expression in a symbolic way, particularly using the conditional probability formula symbols is not a requirement. And even this thing is not a requirement over here. You just need to start your working by these values. All right. So green, blue or blue, green. So green, blue means 5 over 9 into 4 over 8 and blue green means 4 over 9 into 5 over 8. So either this case or this case. So both will be added. So 5 over 18 plus 5 over 18, which is 10 over 18, and in a simplified form, 5 over 9 is your answer. So your answer to part B is 5 over 9. So now let's move on to part C. The requirement of part C is to find the probability that all three marbles selected are the same color. Okay, so same color means all three marbles same color. So green, 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 of which first two are from bag X and the third one is from bag Y, or you can say blue, 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 out of which first two are from bag X and the third one is from bag Y. Okay, so either green, green, green or blue, blue, blue. So this means 5 over 9 into 4 over 8 into 8 over 13. 5 over 9 into 4 over 8 into 8 over 13. Okay. Or blue, blue, blue. 4 over 9 into 3 over 8 into 7 over 18. So you evaluated these individual values. So this is 20 over 117 plus 7 over 78. Okay. I'll just erase it and write it clearly. 20 over 117 plus 7 over 78. This is supposed to be 61 over 234. So this was the requirement of part C. After this, we have part D. It is said that given that all three marbles selected are the same color. Okay, one condition is given to you, one restriction is given to you. So find the probability that they all are green. They are all green. Okay, so this is basically the way of saying that you need to find the conditional probability over here. Okay, the question is saying that find the probability that they are all green given that all three marbles selected are the same color. Same color. Okay, so for part D, I've done the working on the next page. So basically, if you want to write a formula for conditional probability, so I've just mentioned this formula for your ease over here, that you need to find the probability that all marbles are green given that all are same color. So this means that all green intersection all same color meaning first you will find the overlap between the event all green marbles and all same color. You will find the overlap over here divided by the probability of all marbles same color. And as a matter of fact that all marbles same color, you have found the value in part C, which is 61 over 234. So what you need to understand is that you just need to think about this thing. All green intersection, all same color. What would be the overlap of these two events? All green, all same color. Obviously, all three of them are green. Okay, if I ask you what is the overlap between these two events, all three green and all three same color. Okay, so green, green, blue, blue. So, obviously you will say that the overlap between these two events is green, green, green. So this is basically the overlap over here of these two events. So green, green, green. Here you can see that green, green, green. 5 over 9 into 4 over 8 into 8 over 13. So you are going to evaluate the numerator over here, which is 20 over 117 divided by 61 over 234. So 40 over 61 is supposed to be your answer. In this way, we have attempted this question, and this question was January 2023, question number 2. So now let's move on to the next question. So now the next question is January 2023, question number 4, same paper. Question number is 4. Question is saying that in the Venn diagram below, A and B are events and P and Q, P, Q, R and S are the probabilities. Okay, P, Q, R, S. And here we have some information that the probability of event A is 7 over 25 and the probability of event B is 1 over 5 and the probability of A intersection B complement union A complement intersection B is 8 over 25. Use algebra to show that 2P plus 2Q plus 2R is equals to 4 over 5. Alright, so first thing first, what we know the fact is that the probability of event A is given to us and B is given to us. Okay, and what we also know the fact that when you want to find the probability of event A, this means P plus Q. These alphabets P plus Q. Okay, so we can say that P plus Q is equals to 7 over 25. We have obtained first equation which is connecting P and Q, where P and Q are unknown right now. Okay, so P plus Q will be equals to 7 over 25. And as we know that, we know the probability of B, which is 1 over 5, and B means Q plus R. We have two values over here, right? Q and R. So when Q and R are added together, they will give us the probability of event B. So we can say that Q plus R is equals to 1 over 5. Okay. And as far as this third condition is concerned over here, which is given to us 8 over 25, what you understand by this thing is that, the union of these two events, A intersection B complement and A complement intersection B. Okay, so we have to observe this. First thing, if we want to see what is A intersection B complement. Okay, so this means that part of event A, which is not the part of B, this thing P, this will be equals to P. If you just observe this thing, A intersection B complement. So the overlap between A and B complement, meaning part of A which is not part of B. So this is equals to P over here. And as far as A complement intersection B is concerned, this means that part of B which is not part of A, meaning if you want to find the overlap between A complement and B. So this is obviously R. Okay, A complement means everything other than A. And overlap with B, this is only R over here. So P plus R, because we are finding the union of these two events. Okay, so this implies the fact that P plus R is equals to 8 over 25. Okay, so we have three equations over here. First one is P plus Q is equals to 7 over 25. Okay. The second one is Q plus R is equals to 1 over 5. And the third one is P plus R is equals to 8 over 25. All right. And what we need to find 2P plus 2Q plus R. So if we add all these three values, what we are actually adding? P plus Q plus R plus P plus R. So P plus Q plus R plus P plus R, meaning P is 2 times, Q is 2 times, and R is also 2 times, which essentially means 2P plus 2Q plus 2R. So adding all these three values together, you will get your required answer in part A. Therefore, 2P plus 2Q plus 2R is equals to 4 over 5. We have added these three values together. As simple as that. You just need to think about it. Okay. Use your concepts which you have studied, and there you go. This was the requirement of part A. I hope the pixels are clear because I actually erased those classwork notes on the day which I discussed these questions, particularly this question in the class. So basically, I've brought the screenshot over here again. Okay, so I hope the pixels are clear. So that's basically the whole thing. So it's good that I save all the classwork notes in screenshots form. So now let's move on to part B. Part B says that find the value of P, the value of Q, and the value of R, and the value of S. So first thing first, what you know, the fact that the sum of all the probabilities is equals to 1. So P plus Q plus R plus S is equals to 1. Okay, first thing first. P plus Q plus R plus S is equals to 1. And as we know that 2P plus 2Q plus 2R is equals to 4 over 5, which we have already established in part A. Okay, so I can say that taking 2 as common, multiply by P plus Q plus R is equals to 4 over 5. So this 2 is gone over here. So I can say that P plus Q plus R is equals to 4 over 10. This makes sense? Simple. And since P plus Q plus R plus S is equals to 1, so in place of P plus Q plus R, you can write 4 over 10. Wonderful. You can easily find the value of S. So S is equals to 1 minus 4 over 10. S is equals to 3 over 5. All right. Then what we know the fact is that P plus Q is equals to 7 over 25. Okay. P plus Q is equals to 7 over 25. So using this equation, P plus Q plus R plus S is equals to 1. In place of P plus Q, we can write 7 over 25. So 7 over 25 plus R plus 3 over 5. In place of S, we can write 3 over 5. So we can easily find the value of R. So R is equals to 1 minus 3 over 5 minus 7 over 25. Wonderful. R is equals to 3 over 25. Okay. Then here I'm going to fit the picture on the whole page. All right. So now, as we know another equation which is Q plus R is equals to 1 over 5. Where is it? Q plus R is equals to 1 over 5. So now we can use it over here. Since we have found the value of R, which is 3 over 25 from the above working. So Q is equals to 1 over 5 minus 3 over 25. Q is equals to 2 over 25. And as the first equation which we knew from the information of the question, that P plus Q is equals to 7 over 25. And since we have found the value of Q, and therefore P is equals to 7 over 25 minus 2 over 25, P is equals to 1 over 5. Okay, so in this way we have attempted part A and part B over here. Okay, this part A and part B. So now let's move on to the next part. So in part 2, it says that two events C and D are such that the probability of event C is x upon x plus 5, and the probability of D is 5 upon x. Okay. C is x upon x plus 5 and D is 5 upon x, where x is a positive constant. So by considering the probability of C plus probability of D, show that C and D cannot be mutually exclusive. Okay, so first thing first, we are going to add these two expressions over here. It's a wonderful question, by the way. I really liked it. So here is the working. Okay, so first I illustrated a basic concept over here. Okay, as you know that event and the complement of an event, they are mutually exclusive. At one time, at one time only the event can happen or its complement can happen. Okay, so obviously this is a established fact that the probability of A plus probability of A complement would be equals to 1, right? So this essentially means that A and A complement are mutually exclusive. Okay, here is the basic idea. So if C and D are mutually exclusive, so C plus D would be equals to 1. If events C and D are mutually exclusive, so this essentially means that the probability of C plus probability of D would be equals to 1. Agreed with this? Because C and D would not have any overlap, the probability of C intersection D would be equal to 0. In this case, we are considering the sum of the probability of C and D. Okay, so if you get the value which is not equal to 1, so this means that C and D, will not be mutually exclusive. So if C and D were mutually exclusive, so the probability of C plus probability of D would be equals to 1. Okay, so here we start the working over here on this page. I'll fit this picture complete on the page. Okay, here you go. So C plus D, we are going to find an expression for the sum of the probability of events C and D. So x upon x plus 5 upon x. So we are going to take the LCM. We are going to express this expression as a single fraction. Okay, so x square plus 5 times x plus 5 completely divided by x times x plus 5. X into x plus 5 will be the LCM. Okay, so x square plus 5x plus 25 divided by x square plus 5x. Now here we need to prove something. Here we need to prove something over here. Okay, since obviously x square plus 5x plus 25 would be greater than x square plus 5x. Make sense or not? Because 25 is being added after x square plus 5x. This makes sense or not? As simple as that. So what we can say is that in this fraction, the numerator is basically greater than the denominator. Okay. So this essentially means that, x square plus 5x plus 25 divided by x square plus 5x is greater than 1. Isn't it? Wonderful. So therefore, we can say that the probability of C plus probability of D is more than 1. Okay. So we have established the fact that the probability of C union D is more than 1. Or you can also say that the probability of C intersection D is greater than 0. Here you have established the fact that the probability of C union D is more than 1. Okay, since the probability of C plus probability of D is more than 1. Or you can also say that probability of C intersection D is greater than 0. It is not equal to 0. If the probability of C intersection D would have been equal to 0, then C and D would be mutually exclusive. So here is some extra explanation over here as well. As you know the fact that in order to make an equation for the probability of C union D, we can say probability of C plus probability of D minus probability of C intersection D. Okay, and since we have established the fact that the probability of C plus probability of D is more than 1. Okay, we have already established this fact, right? So probability of C union D would be more than 1 and probability of C intersection D would be something other than 0. Would be something other than 0, and obviously it can only be positive since the probabilities are always positive. Okay, either they are equal to 0 or they are more than 0. So C intersection D should be something more than zero. Strictly speaking, it should be more than zero. So here I have mentioned this thing as well, that if C and D are mutually exclusive, so C intersection D should be equal to zero, and the probability of C union D would be equals to one, because this would imply the fact that the probability of C plus probability of D, which would be equals to one. In the same way I explained above that the sum of A and A complement, they would be equals to 1 because they are mutually exclusive. Okay, so in this way we have attempted our question. And one more thing which I like to mention over here, okay, that when we say that the probability of C plus probability of D is more than 1, okay, and therefore we establish this thing that the probability of C union D is more than 1. Either you can write this thing, or you can say this thing, that the probability of C intersection D is more than 0, and therefore C and D are not mutually exclusive. So the order for this is like this. First you, after mentioning this thing, you write either this thing or this thing, and then you finally conclude your answer that C and D are not mutually exclusive. But the question arises in a sane mind that, sir, when you are saying that the probability of C plus probability of D is more than 1, and you are also mentioning this thing that the probability of C union D is more than 1, so it means that both are equal? No, they are not equal. They would have been equal if C and D were mutually exclusive. Because here the extra explanation which I gave, since you know this equation, right? This is basically the relationship between any two events. So if probability of C union D is equal to the probability of C plus probability of D, this would imply the fact that the probability of C intersection D is equal to 0. And when C intersection D is equal to 0, this means that there is no overlap between C and D, and therefore C and D are mutually exclusive. But this is not the case. So if anyone says that the probability of C union D is equal to the probability of C plus the probability of D, so this is not the case over here, because this would be true if C and D were mutually exclusive. Okay, this is basically the whole scenario, and both would be equals to 1, as you can see over here. However, in this case, first we establish that the probability of C plus probability of D is more than 1. Okay, it would be some value more than 1, and this would also imply that the probability of C union D would be more than 1, where the value would be something else other than this value. Okay, what I'm trying to say is that these two things are not equal, and this would obviously imply the fact that probability of C intersection D is something other than 0. There is a positive value of C intersection D. Okay, and therefore the probability of C intersection D is greater than 0. So this is basically the order in which you write your answer. First you mention this expression, then either you can mention this expression or this one, and then finally you conclude your answer that C and D are not mutually exclusive. So in this way, the discussion of this question is complete. So for the sake of this video, for the purpose of this video, I have discussed two questions over here. This one was January 2023, question number 4, and the earlier one was question number 2 of the same paper. Okay, so I'll be uploading more videos soon. So stay tuned to my channel. Thanks for watching. Assalamu alaikum.